we did some order of operations work last week. We had some homework that we took home, went through some problems. Just want to see where we stand on that. So I'm going to see if I can give you some problems and let's see if we can work through them, okay? Let me start with one that you may have seen. So let me get some help on this one. Which operation would we perform first in order of operations? Divide. Okay. Did you say yes? Okay. Why do you think dividing there?
I don't know, that's what I was taught.
Oh. Well, you had a good teacher, I'll tell you that. So in the order of operations, we have multiplication, subtraction, and division up here, right? You said do division first. What was it that you were taught that told you to do that division?
I think it was like
Okay.
parentheses, divide, and something like that. And
Okay.
Times, add or subtract, something like that.
It's all right. So if we're just to write those things down, just say, okay, the first thing we do, what would you guys say is the first thing that we're going to do?
Parentheses.
Okay, parentheses. Okay. We can say parentheses, but the thing about parentheses is that's only one symbol. That's only one set of symbols because we used some other ones last week, right? We used these ones. Let's go insert. There. Grab one of these. Spot right here, actually. Go. We used these braces last week, right? That's kind of the worst drawing of them, but they were in the calculator. We used braces. You could use brackets. Another thing that will group them, we were doing this last week as well. We would do a division line, and that division line told us to do what was on the top and the bottom before we did the division. So that grouped it. So it's all things that group. So I think if we're going to say the first thing to do, it's things that group. So we could say group, but those are all just different symbols, right? So we could say grouping symbols. Maybe we could take this one down. We can all build our order of operations together. You guys mind? Writing down that number one, we're going to do grouping symbols. There could be other, but it's any symbol that's going to group those operations together and tell you to do them first. No problem. Okay. So after we've done whatever is in those, or we are going to perform what's in those, what things would we do next?
Exponents.
Okay, exponents. Now there's an operation that's actually the opposite of an exponent. So exponents, a lot of times they'll be like little numbers at the top, right? Like a little 2 or 3 or something like that, right? That's an exponent. Do you know what undoes those things? Or is the inverse operation opposite? So if we square something, but we want to undo squaring something, multiplying is this over and over again. Okay, so the opposite of that would be what? Opposite of multiplying? Division. Okay, cool. So you're on the next one. How about on this one though, if we have the exponents, what could we do to undo a square? Another operation has the word square in it. We use it sometimes.
Square root.
Square root. Okay, so square root will undo a square. It's how many times something times itself 2 times will equal that. But if we cube something, right, times itself 3 times, and we need to undo that, we're going to do a root still, except this one we're going to do a cube root. Do a third root. Second root, third root, right? Okay, so we could go on and on. But we're going to do either one of these, and we're going to do those the opposites, whichever one they are. So we have exponents, or let's the opposite of an exponent?
Root.
A root. A root, square root only works for squaring, whereas other roots work for multiplying numerous times. And what order do we do things if they're on the same level? If we have a root, or we have a square, which one would we do first?
The root,
Why?
because you go from left to right.
Left to right. Cool. All right. We are lucky. We live in a country that most things that we read, when we read them in English, we read which way? Left to right. Okay. If you're in China, they go from like top to bottom. Okay. We are left to right, and they go backwards, right to left. Thank goodness we live in the United States, where most literature is done in English that taught us to go left to right, and it stays the same in mathematics. We're going to go left to right. I'm just going to put that overarching, a big left to right, left to right. Okay. After we've done the exponents or roots, what would we do next? I think we already heard it from some people. What do you think, Sammy? If we do exponents comes exponents and roots, like parentheses, exponents. Which thing up here? Okay, awesome. Okay, so we're gonna do division. Or what's the opposite of division? Okay, we're multiplying. And how do we know which one to do first, Savannah? If we're multiplying or division, which one? How do we know how to do which one first? They're on kind of the same level, right? We're gonna do this one, but I think Abel and Gabriel both said when we're on the same level, we go from where? Left to right. Okay, so that's why my new friend Ramona had Ramona, right? Ramona. I'm sorry. Even better. Ramona. She said do division first up here because she was going left to right. Okay. And then there's one more level. Adding or subtracting. Okay. Why are adding or subtracting on the same level? Because they're opposites. Okay. So we're either adding something in or taking it out. We did that a while ago. Oh, we added things in and took them out. What was that, Enrique? What were we using to add things in and take? The cubes, right? Awesome. Good memories in here. So, on this one, let's go ahead and work this one out together. If we're going to follow those rules, what are we going to do first? Divide? Okay, well, we don't have any grouping symbols. Do we have any exponents or roots?
No.
We have division or multiplication, right? So we go, ooh, we got both of them. Left to right, the division comes first. So 12 divided by 4? 3. Okay, so what I liked on the assignment we did last week, it said to write out these steps. It said, what do you do first? Okay, so we do 12 divided by 4 first. Okay, I think we wrote it in words actually. Okay, and what's 12 divided by 4? 3. Okay. It's 3. What would be the next thing we would do after we did that?
Subtract 8 times 3, which equals 24, and then we would subtract them, and it would be negative 1 or something like that.
Maybe.
Subtract 8 by 3.
I like what you did. You did a lot of things. So the first thing I heard you do was say you subtracted the 8 times 3, and then you did the 8 times 3. So what was the next thing you did?
Subtract them.
But when you had them, you did dot operation first, right?
Yes.
What operation is that? This little dot.
Not division, multiplication.
Correct. Okay, so you did 8 times 3, which equals, and you said that was
24.
24? Okay.
the other way and it would equal negative.
Which one am I minusing from which one? What?
3 from 24.
3 from 24. So 24 take away 3 or 3 take away 24?
It would be 3 take away 24, which equals negative 21.
Okay.
Because both are what's it called? Positive.
Because they're both positive. Oh, good point. So this equal 3, right? And this equal 24. So 3 take away 24. 3.
But if it was the other way, it would be, if there were negatives or anyway, it would be I'm losing my thought.
Oh, it's okay. Yeah. If we switch those around, is what you're saying? And we had 24 and we took away 3.
It would be a positive.
Positive 24. Well put. Thank you. Just explain that very well.
I was losing my thought and I didn't know what I was going to say.
It was a lot of thinking, Sammy. I wasn't going to expect you that much. Great job. Bless you. Let me ask you guys to do one on your own. Okay, and please write out the steps that you would follow for that one. And in what order? So let's review our steps that you guys did. I think some of you are done, some of you are still in the middle. What was the first step that you did in this one, according to the order of operations? Or which was the first step you took, Enrique? Dividing what? Divided by what?
16 divided by 2.
Okay, so 16 divided by 2.
Used to do it from left to right.
What that equal? 8, okay. So now, we already did this part of the problem, right? So 16 divided by 2, now all of that is 8. But we still have these operations to do. So negative 8 plus that, and this plus 7. Alright? Thank you. Okay. Wrong. Oh gosh. I want to say wrong so bad. Wrong. No. Okay. Able. Able. Okay. So after we did the dividing by 2, what was the next operation you performed?
Negative 8 plus positive 8.
Okay, why did you choose this first?
Because we know that's right.
That's right.
The positive 8's in the middle.
Okay, and what operations do you see here?
Negative plus
What's this operation?
Yeah.
What's this operation? Adding, subtracting, multiplying, dividing.
Well, my first answer was 0 because I was thinking of hot and cold.
Okay. Here, we'll go ahead and do that. All right. So you said do the negative 8 plus positive 8. Negative 8. I think that's the word. Positive 8. And what's negative 8 plus positive 8?
16. 8. Yeah.
Which one? 16?
Yeah.
Okay. All right. 16. So, and you said you used hot and cold cubes for that?
Well, that was the one I got 0 because I was like, all right, I just subtracted it and then I added it after I found out.
So, what kind of cubes are these?
Cold.
Cold. So you put in 8 cold cubes. What happens to the temperature when you put in cold cubes?
You just cold it.
It gets colder. Okay, so it went down. And then we added what kind of cubes?
Hot.
Hot. So when you add hot cubes, what happens to the temperature?
It goes back up.
Back it up. So we went down 8 and then we went up how many?
8.
8. So we went down 8 and up 8. Where are we?
Negative, just neutral.
Neutral. I like that. Neutral. No. Okay. 0 temperature, right? So okay. Then you said 16 also.
So I got it right the first time.
Possibly. Let's see. Let me check with Sammy. Sammy, when you added negative 8 and positive 8, what'd you get?
I got 0.
0? Okay. Because the temperature would have gone back to 0. Okay. So do you want me to change this to 0?
Yeah, I thought I did something wrong, so I just,
It's always good to check yourself. I also like checking with other people. So if I do a math problem, Mr. Rumbo's the one I ask about it. So now this problem went from negative 8 plus positive 8 plus 7 to 0 plus 7. All right. And last thing that you did, Gabriel? What'd you say?
7.
Okay, it is 7, but what did you do to get that 7?
I
7
7.
plus what?
0.
Okay, 7 plus 0. Or actually, in this right to left, we read it.
0 plus 7.
There you go. Okay. 0 plus 7. And that equals. Thank you. Alright. Okay. Let's try one more with a new grouping symbol. Try listing that one out, and then also try listing what the problem becomes after you do each step. I'll leave that example.
And I was on top, so I just,
So let's take a look at this one in the same format as this last one. Okay. So first thing that we're going to do in here, and paying attention to this order of operations. See, Sammy, what was the first thing you did on this problem?
26 minus 5 equals 21, and then you divide by
Well, you like doing the whole problem, don't you? You're awesome at that. Can you do one step at a time? So just, you said,
26 minus 5,
and I want to know why you started with 26 minus
because it would be the very first one you would start with.
5. Why'd you start with that?
Because if you the first one there,
Do we have something up there that tells you to do that first?
then it'd be. Actually, I forgot what I was gonna say.
Okay. Is there a symbol up here that's telling you to do it first?
You'd be subtracting.
True. Okay, the subtraction. But subtraction usually comes down here at the bottom, huh? But you're right. You said do it first. But why? What on here told you to do it first?
Because
Yeah.
it's a fraction.
It's on a fraction bar, right? It's above the fraction bar, which is the same as a division line, right?
Yeah.
It's dividing. Awesome. Thank you so much. So it's a grouping symbol. There's a grouping symbol here that says do that first and then do that division. Excellent work. Thank you. So you did 26 minus 5, and you got 21, okay? And so the problem afterwards looks like 21 divided by 3 minus 2. Okay, let me let someone else have a chance, but you're doing amazing. Thank you. Okay, Abel, after you get it right here, you have the division and the subtraction. Which one are you going to do next?
you're gonna divide it,
Okay, what number are we dividing?
3 into 21, or
3 to, wait, 3 into 21?
3 divided by 21.
Okay, 3 divided by 21. So, if 3 cut up into 21 pieces, that seems like it'd be a lot of pieces. What did you get when you did that?
7.
7? Okay. So 3 divided by 21. What you did? Yeah. Okay. Equals 7. All right. So if we have 3 of something, right? What do you like to eat?
Cookies.
Really well. So if you got cookies, they work well because they're delicious. All right, so you've got 3 cookies, right? They usually come in circle form, right? And we divide that into 21 pieces. Let's see. Well, we could start by going 1, 2, 3, 3. Now we have 9 thirds, right? If we keep cutting, it's going to be even smaller. Into, right? If we keep going, it's just going to get smaller and smaller, and they're going to be fractions of cookies, huh? But you said 7 wholes. So what were we dividing into pieces? Were we dividing the 3 into 21 pieces?
We were to put it in 21.
Into how many pieces?
3.
Into 3, right? So we took 21 of something and split it into 3 different groups.
Yeah.
So, oh, okay, well let's, that's what you did and got the 7, and that's what this says to do. But I think we need to say it different. Instead of 3 divided by 21, we need to say,
And then I just put,
can Nassim,
divided by 3.
can Nassim help you out?
I don't care.
No, he was saying what you were saying also. Just want to hear him say it a little louder. Yeah, 21 divided by 3. Does that sound like what you did, Abel?
Yeah.
21 divided by 3. Alright, awesome. 21 divided by 3. So now this is equal to what's
7.
7? Okay, so 7. And the last thing we did, Enrique?
7 take away 2.
7 take away 2
Equals 5.
Okay. Equals 5. And this problem now equals 5, right? Okay. These are awesome. Let's try one more. I'm gonna throw in another grouping. Okay. So, did we all get an answer? Almost to an answer? In there. Let's see. Enrique, can you start us off? What did you start with?
Started with negative 13.
Okay, why -1 times -13 does equal positive 13. I'll tell you that. What why did you start with that?
Because it's in the parentheses and multiplication comes first and addition.
Multiplication comes before addition. It's in the parentheses.
Yeah.
Why didn't you do this division first?
Because like I use handouts parentheses first.
Oh, okay. Good point. Parentheses before division.
Yeah.
But we actually, okay. What does this thing tell you to do? Do the top first. Okay, so we did the top, and then in the top we had parentheses, so we could keep going with parentheses and lines over and over again, huh? Alright, so that was right. You said do the -1 times -13, and that equaled positive 13.
Yeah.
So if we just rewrite this whole thing without that expression, it equals, well, with that expression equaling 13, we have this, correct? Yeah? Okay. Abel, what did you do next on here?
I did the 7 and 13.
7 and 13 because
That's the next step.
what on there tells you it's the next step?
The division bars and the parentheses.
Right there, division bar and parentheses. Man, all right. So he said do division bar and then do in the parentheses. So what do we get when we get that?
Negative. That would be good for 20.
20. Okay, 20. Awesome. Positive 20. Okay. So now we have all this stuff. Gabriel, what'd you do next?
Multiply -4 and 22.
-4 and 20. What's -4 times 20?
-80.
-80. Okay. -80. Okay, so we got this. All right. And Nassim, what'd you do next? -80 divided by 5. Awesome. Thank you. Okay. Why did you do this and not this part? Why'd you do division before the subtraction? Did you follow this thing?
Yeah.
Okay, and which one were you on when you did the division? Were you on 1, 2, 3, or 4? 3, right? Okay, right here on 3 it says division and multiplication, then subtraction. All right, what'd you get when you did that?
-16.
-16? Is that what you guys got?
Yeah.
Okay, I would have to use a calculator. I can't count by fives that high. Okay, so we still have this. Great job, thank you so much. And Savannah, we have this left. What'd you do?
You gotta make the subtraction, adding, and
Not
then
just hot
make
cubes.
the 6 negative, and then.
Okay. You made that, and that. Yeah.
And it's -22.
Negative 22. Alright, negative 22. Okay. She changed that whole cube situation around, huh? Completely. She changed that. Well, let's see. Sammy, you were here for the hot and cold cubes? Yeah. Okay, so originally, let's see if it still works. I'm gonna leave yours, what you changed it into. But I'm gonna take it over here and say, if these were hot and cold cubes, what kind of cubes are these?
Negative.
Hot or cold?
Cool.
Okay, so we put in 16 cold. So what happens to the temperature of something when you put like ice cubes into it? Does the temperature go up or down when you put in ice cubes?
It goes down.
Goes down. So we went down 16 degrees. And then we added
Yeah.
6, what kind of cubes?
Cold.
6 more cold. So what happens to the temperature when you add more cold?
It goes lower.
Goes lower. Okay, so we're at 16 and we went down 6 more. So where are we?
You're at,
I like to use fingers first. 16.
you'd be subtracting by it, but.
We went from 16 down 6 more. So 17.
Maybe 20, negative 22.
Me too. Me too. Okay, negative 20. Oh, we got the same thing when we use the cubes. Thank you so much. Just want to make sure our methods still work. You're awesome, Savannah. And Sammy, great memory. Thank you. All right. So this was kind of a review of the things we did last week. Let's do something new with this information. So we can turn over to those investigation sheets. They're kind of stapled together. Look like worksheets sort of, but it's just really how you're going to follow along. So we're going to talk about undoing operations now. We were doing the operations before. Now we're going to talk about undoing. So let me throw something out. I'm thinking of a number. I have a number. I have a magic secret number. And if I times it by 2 and add 1, I get 11. What was my secret number?
5.
5. How'd you get that?
2 times 5 is 10, plus 1 is 11.
Okay, alright. I believe that. That sounds alright. Oh wait, that was the number I was thinking of. Alright. I am thinking of a number. If you multiply it by 3 and subtract 2, you get 7. What's my number?
3.
3? How do you get 3?
Because you do 3 times 3 equals 9. Take away 2 to get 7.
7? Bam! Excellent work. Okay. So, yeah. Alright. That's just guessing my secret number. Now, I'm going to get some other secret numbers. Alright, so I've got a secret number. Hold on. Got it. Alright, so, I'll give you some clues as to how you guess it. I picked that number, divided it by 4, added 7, multiplied by 2, then I subtracted 8, and I got 28. You know what my number is? I think this seems really close. Okay. It's kind of messing with you. It has a lot of things to do, I know. And I don't expect you to do it in your head. I mean, you might be able to. I can't. I'm a little older. My brain doesn't work as well. So when I see things like this, I'm like, okay, what can I do? How can I organize it? Well, let's try organizing it in a table. Well, tables work amazing for looking for patterns, right? This is just a pattern. You guys were doing amazing patterns. All right, I did this and then I did that. So I picked a number, divided by 4, added 7, multiplied by 2, subtracted 8. This sequence, this is what our calculator would look like. This is So if we did it in this exact calculator, if we did that, we took some number and then we divided by 4, it's gonna say A and S. You guys saw that last week, that when you do something over and over again, it's gonna say A and S or answer. Now the expressions, do those make sense to you? So, you don't know my number, so what did they put, because you don't know my number? They put an X, alright? And there's a big reason why they use X in math. I'll explain it later. But, what about here? What did we do to that X? Divide by 4. Then what did we do to X divided by 4? That's 7. Then what did we do to X divided by 4 plus 7? Multiply by 2. Okay, now what did we do to 2 times X divided by 4 plus 7? Minus 8. Oh, okay. Alright, now see why they wrote that. So if we're gonna undo each one of these steps, like that's what you guys were doing in your head. You're like, okay, it was something divided times 3, and if I subtract 2, so I'm gonna add 2, and then, okay? So if we're undoing those steps, we can't really start with the undoing of this picking a number, right? I just picked the number. You can't make me undo that, right? That's already in there. However, you can undo these things I did to it, right? So how do we undo dividing by 4? The opposite of dividing by 4. Right? Multiply by what? By 4. Okay? Multiply by 4. So let's fill in the charts. We can get used to using this to find out secret numbers. Okay? Next we added 7. So how do we undo adding 7? Opposite. Subtract 7. Okay? Then I took that answer and I multiplied it by 2. How do we undo multiplying by 2? Divide by 2. Okay. And finally, so add what? So we subtracted 8, so we're going to add 8. Okay, adding 8. So these are all those things. All those opposites, all those undos. And when we did all that, what did I get? When I took my number and did all those things? I got 28, right? So when I did all these things to it, I got 28. So we're going to put a 28 down here to show that that's the result of doing all these operations to my secret number. Okay, so now we're just going to do what you guys did in your head when you could figure out my secret number. We're going to do it on this paper. So let's take that 28 and let's do that opposite. So instead of, let's add 8 to it. 28 plus 8 equals, let's see, 28. Like I said, I like to use fingers. So 28, 39, 30, 31, 32, 33, 34, 35, 36. Okay. Okay. I believed you guys. I just wanted to check with my fingers. Thank you. All right. So let's check with the PowerPoint. Okay. Awesome. So now we have 36, and we got to do this to it. So 36 divided by 2 equals. Okay, I like to get answers from multiple people. Let's see. Anyone else? What's that? 28. 28. Thank you. 18. 28. Anyone else? 28. Okay, how'd you get 20?
By subtracting by 7.
Oh, we're right here. We're doing 36. Okay.
Oh.
36 divided by 2.
Oh.
I know, it looks kind of weird the way it's set up, but just 36 divided by 2. 12. How'd you get 18?
18 plus 18 equals 36.
Oh, 18 plus 18. Does 18 plus 18 equal 56? Okay, so how many 18s did that take? 2. So 2 times 18 should equal 36, which is undoing the division. So 36 divided by 2, 18. Thank you, Missy. Let's do the same thing. That 18 divided by 7 should equal, or I'm sorry, 18 subtract 7.
11.
11. Okay, we can agree on that one. That's fine. Works for me. All right, 18 minus 7, 11, and 11 times 4 equals. Check that one. Thank you. Appreciate that. 44, 44. Okay, so 4 11s is going to equal. All right, 44. Guess what my secret number was?
42.
Yes, my secret number was 44. Good job. Okay. So even though I took that big number and I did all these things to it, it was pretty simple to figure out what my number was, right? Okay. So let's see. You guys just solve the equation. This equation right here. Okay. All right. This was what I did to all mine, and that is what my result was. Solution is 44, or we can say that x in that problem, or my unknown, is equal to 44. So an equation, we talked about expressions last time. Expressions were just operations and numbers. It was like the 2 times 3 plus 4 divided by 8, okay? That's expression, but when you take two expressions and place them equal to each other, or two things that are the same value, like that expression that I did to the number and the 44, those are equal, and therefore it's an equation. So when we're solving for equation, we're trying to figure out some part of it that we don't know. So if we have an equation and we don't know a piece of it, we're going to solve the equation by undoing all those operations, and that gives us a solution. Solution to the equation is that value that makes the expression work, or the equation work, sorry. That makes that equation work out to the 28. So, lots of times we can undo operations and find it, and I think these are listed on the bottom of the second page, or it says 28. Bottom of 28. The steps to follow for undoing these operations, solve it, is complete the description column, right? We're going to list that description of what we did. You guys did that a bunch of times today, huh? You wrote out all the things you would do in what order. Then we complete an undo column. How do we undo all those things? And finally, we're going to work backwards up that table. We're going to work up that table to undo each one of those steps. And once we get to that top, what we think the solution is going to be, we're going to check it by putting it back into the original equation. Okay, so instead of having the x, we're going to put in the number that we found after undoing it, and see if that works in the equation. See if that makes it equal. So on this one, we don't know this one, right? We don't know this. This is some secret number, and we need to make this value come out to equal that 11. We need to find out what number or what value we can put into that x. So let's list the things that we would do if we knew what that x was. What's the first thing we would do if we knew what that x was? If it was a 5, what would you do to the 5 first? Subtract 4. Why subtract 4?
Because the grouping symbol and the parentheses.
You guys are experts now. Okay, so said to subtract 4, right? Awesome. Good reason. Second thing that we would do, Savannah.
Multiply 2.
Multiply by 2, okay? Because multiplication comes next. Okay. Next thing, Enrique. Oops. Add 3 to that solution. Okay. Add 3. And now that we've done all that stuff up on top, what are we gonna do, Nassim? Divide by the 5. Okay, we'll divide it by the 5. And finally, Gabriel, after we've done all this stuff, what do we have left to do? Add it by 6. Add the 6. Okay? So we do all those things. So if we did want to find that, what was the result? Or if we did know what the number was, or I did it with my secret number, what was the result? Would that equal?
15.
Possibly. But when we did this to my secret number, what was the result? 11. It came out to an 11. Okay? So, does this make sense for mine? I know how, you're like, oh, 15. Okay, so we did all these things to my number. The result came out to 11. And if we do the undoing, what's the undoing of subtract 4? Add 4, okay? The undoing of multiply by 2? Divide by 2. Undoing adding 3? Subtract 3. Dividing by 5? Multiplying by 5. Adding 6? Subtract 6. And my result's 11. So 11 minus 6?
5.
And then 5 times 5? And 25 minus 3? And what did we do here? Divided what? Divided by 2 equals, and then what do we do here, Gabriel?
Add 4.
What do we add 4 to? 11 plus 4 equals 15. Yep, secret number was 15. Alright. So, let's see. Let's walk through this then. Okay, if we took 15 and minus 4, what would we get? 15 take away 4 would be 11, okay? So what's 11 times 2? 22. What's 22 plus 3? 25. And 25 divided by 5? 5. And 5 plus 6? Oh, there it is. Okay? So let's, you guys already have this on yours, on the 3rd page. There is one for you, already made up. So what we need to do is take this equation, and it has a number that we don't know, right? We don't know what that x is, it's a secret number. Let's write this equation up here, and then list what we do in the order of operations, list the undo, and list the result, okay? Sure. Yes, sir, sir.
Never found that this time. I think it's a better time.
Okay. So once I've picked the number, once I have the x, what's the first thing you would do to the x up here in order of operations? Oh, minus 3. Yeah, minus 3. Okay. Thank you, sir. After we minus the 3, what would we do?
Divide by 4.
Divide by 4. Which one? Add or subtract? Add the 7. Okay, add the 7. Now, tricky thing is, there's still 2 extra boxes, huh? But did we do anything else to it? No, so we're okay. All right, let's find the undo. What do we do to undo these ones?
Add 3.
Okay, starting up here, add 3. Multiply by 4. And subtract 7. And when I did all these things to the secret number, what did we get? What was the result?
42.
42, all right. 42. I always like to use different colors. So, take the 42 and undo these operations to it. Okay? Let's perform these operations back. Okay? How'd you get 35?